What's up, sports fans? Algebra 1, Semester 1, Final Review Guide. This is problems 1, 2, and 3. For the other problems, check the other video. I split it up. Okay, number 1. We're given this equation, y equals negative x squared plus 2x plus 3. Notice a couple things. 1, I changed my y into an f of x because we're going to use some function notation. I'd encourage you to do the same. Second, this is a quadratic. There's a square in here. That means it's going to be a parabola. It's going to be that smiley face or that frowny face. We don't know which yet, but we're going to find out. We're going to explain this with a table. We're going to explain this with a graph. I've given you the x values right here. They're not on your sheet of paper. They're right here. So use these. On the actual exam, I'm giving you these values. So don't stress about finding them. Now, our task is to find the y's. That's what kind of this mess over here is. I ran out of space. Hopefully you can do yours a little more cleanly. So what I've done is I wrote the same exact thing 5 different times here. And in parentheses, this is where the x's are in our original function. So f of x equals negative x squared plus 2x plus 3. So what I'm going to do is I'm going to plug in each of these x values, negative 1. So I'll have the negative 1 in for each of these x values, and then we're going to PEMDAS it and figure out what the value of f of negative 1 is. And then we'll do the same for all the others as well. So it's a little time consuming and a little just like taking care of details. But the math itself isn't crazy. So here we go. Negative 1 squared is positive 1, but this negative sign comes down. So there's a negative 1 right there. And I'll throw my equal sign in here. 2 times negative 1 is negative 2, and then we add 3. So negative 1 minus 2, well, that's negative 3. Negative number gets negative, right? So we're at negative 3 plus 3, that's 0. So what we just learned here is f of negative 1 is 0. So that's where this 0 comes from. Okay, let's do the same thing with f of 0. F of 0 should be everybody's favorites because 0 squared is 0, negative 0 is 0. Cool. 2 times 0, also 0. So now we're at 0 plus 0, that's 0. 0 plus 3, however, is 3. So f of 0 is 3. Moving on, f of 1. Boom, boom, boom. 1 squared is 1. Negative, though, so it's a negative 1 plus 2 times 1. 2 times 1 is 2, plus 3. Negative 1 plus 2, negative 1 plus 2, that's positive 1. Positive 1 plus 3 equals positive 4. Keep going. F of 2. Plug in 2 into everywhere there was an x. 2 squared is 4. But it's negative, so we have a negative 4 right here. Plus 2 times 2, that's positive 4. Plus 3. Negative 4 plus 4 is 0. 0 plus 3 is 3. Gosh, these are super close together. Sorry about that. Last one, f of 3. Plug 3 in all the way across. 3 squared is 9, but again, that negative sign is still out front. We're not squaring the negative sign out front. So we have a negative 9 plus 2 times 3. Well, that's 6, and then 3 is still 3. Negative 9 plus 6, that's negative 3. Negative 3 plus 3 is 0. So this value here is 0. Okay, we've populated our table. Neato. Notice how it's symmetric. Right here in the middle, we have a 4, and then as it grows out, the blue numbers match, and then as it grows out, the next red numbers match. That'll always happen with the quadratic. That's how we get that parabola shape. Let's plot these dots to see what the graph looks like. So negative 1, 0. Starting from the origin, negative 1, 0 is this point right here. 0, 3, 1, 2, 3 is this point right here. 1, 4 is this point here. 1, 4, nice, I'm getting into my stuff here, whoops. 2, 3, 1, 2, 1, 1, 2, 1, 2, yeah, there it is, okay. Great, great, great. So the graph is gonna be all messed up with my algebra, whoops. And then 3, 0. Connect the dots. Remember, this should form a U type of shape, in this case an upside down U, not a V type of shape. It's not a point, it is a rounded kind of meeting there at the turnaround point or a vertex. Okay, then we're asked, let's see what the exact words are, listing its characteristics. So the first thing I want you to see is that this first, if we read this thing from left to right, just like you would read anything, like you'd read a book, like you'd read a text message, whatever, if you read it from left to right, the graph goes up, and then it turns around at the turnaround point and goes back down. So we'd say that this thing increases, then decreases. If we read it left to right, increases, then it goes back down and decreases. Okay, cool. Let's also list the vertex. The vertex is that turnaround point. It's always easy to identify once you have the parabola here. Our vertex is at 1, 4. Let's see, our zeros, or our x-intercepts, is, well, they're right here where the graph crosses the x-axis. So when we list our x-intercepts, we don't have to list the y-coordinate of that because we know the y-coordinate is 0. That's by definition of what an x-intercept is. If it's touching this x-axis, it has not gone up or down on the y-axis. So we can just say our x-intercepts are at -1 and 3. Oops, -1 and 3. Please don't list it like 1, 4. That's a totally different meaning. This is an ordered pair indicating an xy ordered pair, and that's not what this is. So our x-intercepts are -1 and 3. In this case, we also have a maximum value. Our maximum value, our maximum height is when y equals 4. Gosh, that looks like 4 equals 4. This is y equals 4, my mistake. If the graph were to be pointing up like a smiley face, then we'd have the minimum value wherever the vertex is. So these are the big characteristics that we're going to look for when graphing a quadratic. You know what? I suppose there's one more. Let's look at the y-intercept. Let's look at this one right here. The y-intercept is at 3. That's where the graph crosses the y-axis. So again, we can just call it 3. We don't need to say 0, 3 because it's implied that the x-coordinate is 0. It must be, by definition. Okay, I'm ready to move on now. Let's look at number 2. We have 4 equations to solve. We're solving each of these for x. So A says 3x minus 10 equals 28. Our goal is to figure out what value of x makes this equation true. That's the goal of every equation solving adventure ever. So the way that we tackle this is we're going to add 10 to both sides, because we're trying to undo everything being done to that x. So we see that 3x equals, well, 28 plus 10 is 38. Now we have x times 3, so we need to divide both sides by 3. And you might notice, or you might have plugged this into your calculator, but 38 is not divisible by 3 evenly. So the end result here is 38 thirds. You can leave it just like that. You don't need to do anything else with it. We're done. That's a precise response. B, it's a quadratic. We're going to deal with that. That's something we learned toward the end of the year in lesson 308. So check your notes for that if you'd like. I'm going to start by subtracting 3 from both sides of the equation because there's a positive 3 here that I'm trying to get rid of. So we have 5x squared equals 80. Now I'm trying to get the x squared by itself in this next step. So we'll divide both sides by 5. And then we learn that x squared equals, well, 80 divided by 5 is 16. So now we have this x squared equals 16. And so we'll take the square root of both sides with the goal of getting this x by itself. Good, we got it by itself, but now we got to deal with the mess on the other side. Square root of 16 you might recognize as 4, but please don't forget the positive and the negative values of 4. Every value has 2 different square roots, the positive and the negative. Well, I guess if there's 1, then there's 2. Not everyone has a perfect square root. Okay, part C, the absolute value of x plus 8 equals 20. The first objective here is to get the absolute stuff in absolute value bars all by itself. So we'll subtract 8 from both sides. Then we see that the absolute value of x equals 12. Now, we know that the absolute value means it's distance away from 0. So we're going to split this thing up into 2 equations. We're going to say x equals 12, and then we're going to say x equals negative 12. And this is kind of a funny one because it's already solved for us. We're done. There's no more solving to be done. We found both of our solutions. In this case, it happens to be 12 and its opposite. That's not always the case. I noticed on the test, a lot of people just assumed it was like a number and its opposite. That's not the case. It's only the case if x is all that you have inside the absolute value bars. But more often than not, it's like an x plus 5 or x minus 7 or whatever the case may be. But the trick is to split it up into 2 equations. Whatever's in the absolute value bars goes on the left. Whatever's on the right side goes on the right. Then on the other one, the absolute value bars go on the left, and then the negative, the opposite, is what goes on the right. Let's keep plugging along. 11 plus 2x equals x minus 1. The first thing I want to do here is get all the x's on the same side. I'm going to send them all to the left in this particular one. So I'll subtract 1x. Don't know why I wrote 1x there, just, and it still works. 11 plus, well, 2x's minus 1x is just 1x. X minus x is 0, minus 1. Great. Subtract 11 from both sides. Be extra careful here. I could see some mistakes being made. We know 11 minus 11 is 0. X is still x. And then we have negative 1 minus 11. A negative number gets negativer. So x is negative 12 here. All right, simplifying some exponent stuff. This is from lesson 303. It's that note sheet that opens up like a cabinet. Please spend some time with that between now and the final. It's important. Okay, so this first one here is the power rule. So these two have the same bases. The bases are both x. This is x times x times x times x times x. That's what x to the 5th power means. X to the 12th power is the same thing, but 12 times. I'm not going to list it out. So if we list all those together, we would have 17 x's all next to each other being multiplied together, and that's just x to the 17th power. The shortcut, though, is just adding the exponents together. So it's x to the 17th power. And again, that's just because 5 plus 12 is 17. Okay, this next one, y squared divided by y to the 5th. That's the quotient rule if you're looking at the note sheet. So to do this one, we would do y to the 2 minus 5th power, whatever's on the top minus whatever's on the bottom. So that one equals y to the negative 3rd power, but that's not done. We don't finish with a negative exponent like this. The negative exponent rule, again, on that same note sheet, lesson 303, tells us that we can just throw that number into the denominator, to the bottom of a fraction, and make the exponent positive. So these have the same value. Y to the negative 3rd equals 1 over y to the 3rd power. C, power of a product rule. Or no, this is a power of a power rule, something like that. So we have x to the 5th, and x to the 5th is being multiplied by itself 10 times. So that means we have x times x times x times x times x 5 times. And then we have those, and we're multiplying that by 10 times. I'm not going to list them all out, but hopefully you can see if you have 5 things, and you have those 5 things 10 times, well, now you have 50 of those things. And that's what's going on here as well. We just multiply the 5 times the 10. So this ends up being x to the 50th power, because 5 times 10 is 50. Again, you could list it all out if you wanted to. I think that's a waste of your time, but you could totally do it and see why it's actually true. We did some of these examples if you want to check the video for lesson 303. All right, last one. This one is, it's more confusing, or it's easier than it looks. It looks more confusing than it is. A lot of people are trying to FOIL this, distribute this, doing some weird stuff. Here, everything is being multiplied. We have x squared times y times z to the 7th times x to the 8th times z to the negative 3rd power. And in this case, where the parentheses are actually irrelevant. They don't really matter. We can move them around. We can get rid of them. And that's what I'm going to do. I'm going to get rid of them, and I'm going to list the values, the like values by next to each other. So I'm going to put the x's by each other. We have x squared times x to the 8th. That's these two pieces. Then we have a y. That's this piece. And then we have two values with a base of z. So I've listed them by each other. So what we were given is equivalent to this. It's all the same pieces of the puzzle, and we're still just multiplying them. I just put the pieces next to each other that should be next to each other. So how many x's are being multiplied? Well, this is x to the 10th times y. And then the z, just be extra careful here. So we're going to add the exponent. 7 plus a negative 3, well, that's 4. So this is z to the 4th power. So x to the 10th times y times z to the 4th power. Okay, long-winded video. I apologize. Feel free to pause, rewind, whatever you need. This is problems 1, 2, and 3. For 4 through 7, check the next one.